What is the maximum value of ln x over x cubed? Obviously, pause the video if you want to have a go in your own time. I'm going to do this the standard way I would solve a question like this. First of all, I'll try and do it graphically. So I've got ln x here. I've got x cubed here. And I'm just going to think about what, while I'm dividing one by the other, what would happen, because there might be a really obvious answer here. What about if x equals 1? In that case, I've got 0 divided by 1, which is 0. That's probably not the maximum value. In fact, we can tell that because if we imagine x is large, let's change colour here. So what if x is large? In that case, ln x is kind of big. And x cubed is really big. So it's positive. It's a positive number, which is obviously bigger than 0. Okay, at this point I give up because I go, this method's not going to work. I'm going to try a different method. Often at this point, obvious answer presents itself. It hasn't. So give up. What's our next approach? Well, it says maximum value. Big clue there. Try differentiation. So let's find out what dy dx is. Dy dx, I'm going to use chain rule here, so I'm going to be really crafty. So let's just start here. So I'm going to say y equals x to the minus 3 ln x. Sorry, so I'm going to use product rule because I don't like using quotient rule. I'm lazy. So then dy dx is x to the minus 3 times 1 over x minus 3 x to the minus 4 ln x. So that was a product rule. I need to make that equal to 0 in order to try and find the turning points. I'm going to do a bit of tidying up as I go along, so I'll rewrite that as x to the minus 4. This one I'm not going to tidy up very much. And I'll put the equals 0 on the right hand side because I just like to do that. Is it linear or non-linear? Because we've got to solve it, obviously. It's non-linear, so we factorise. So that'll be x to the minus 4. 1 minus 3 ln x. Right, well, I'm going to write not possible, because that would be like x equals infinity. Anyway, not possible. So this must be the answer we're interested in. 1 minus 3 ln x equals 0. Rearrange that, we end up with ln x equals a third. So x equals e to the third. So we've only found one turning point. The question implied that it was a maximum, so we could just call it a day here and say, well, that must be where the maximum occurs. Let's find out what y is. I'm using y. Y wasn't using the question, but I've just introduced it to make it easier to talk about. So that's just ln of e to the third divided by e to the third cubed. Now we can sort of rearrange that. The ln and the e cancel, just making a third. And then the 3 and the third cancel because they do, because one is a cube root, one is cubed, etc. And then that makes e to the minus 1. Just found the maximum value. I did make an assumption there. I assumed that that was the maximum value. That bothers me. If it bothers you, let's as well. Hang on in there. Let's look at this. Let's check it really was the maximum. I'm going to write dy dx again and try and tidy up a bit more, so I'm ready to differentiate it again, and I'm making my life easier. This is one of those places where I think simplifying is a good idea. I'm going to use chain rule on this bit. So d2y dx squared, that'll be minus 4x to the minus 5, because I brought the power down, minus 1, plus 12x to the minus, and then the chain rule on this. I could do a lot of simplifying here. The 1 over x becomes part of x to the minus 4, making x to the minus 5, which means we can bring those terms together, etc. And we end up with minus 7 x to the minus 5 plus 12 x to the minus 5 ln x. Now the question is it a maximum or a minimum? So we need to know whether it's less. We need to put in the value x equals e to the third and see what happens. So let's do that. I'm going to switch the order around now because I like to have the positive thing on the left. Just subbing those numbers in. I'm going to go quite fast here. That becomes 4. And, oh look, 4 minus 7 of something must be less than 0, so that must be a maximum. Now, I have skated over one thing which I think some people will wonder what I've done. So, you might be happy there, in which case, thanks for watching. You might be wondering where this came from. So I just reinforced the indices rule I was using. That was x to the minus 5, which became e to the third to the minus 5, which became e to the minus 5 over 3 because I multiplied the powers together, or I thought about it some other way. There we go.